Okay, we're going to get started. We have a session now of the three last talks of the day, after which we'll have a panel discussion. We're very fortunate to have the luck of having visitors come from Poland, and it just worked perfectly that we could give our wetland culture concept, and then they would complement it by telling us what's going on in Poland, where they've got issues related to reservoir pollution, but also ultimately the Baltic Sea, which is in many respects comparable to our Great Lakes, although the Baltic Sea is, of course, brackish water. So our first speaker in this session is Edyta Kiedrzyńska. She is Deputy Director of the European Regional Center for Ecohydrology of the Polish Academy of Science. There'll be a quiz on this, on Łódź. It looks like L-O-D-Z to us, but it's Łódź. Do I have that right?
Yeah.
Poland, and as well as science and teaching at the University of Łódź. Her research interests include phytotechnologies, wetlands, river hydrology, nutrient cycling, and sedimentations. She's been the winner of a Scientific Research Day Scholarship awarded by the Ambassador of France in Poland and the Institut Français et Poland. That's pretty bad French. Awarded by the Ambassador, or funded by the French government. She is scientific board member of the international journals Ecohydrology and Hydroecology, and Scientific Reports Nature Journal. She is also a member of the UNESCO International Hydrologic Program, National Committee for the period of 2019 to 2022, and I believe part of your travel support to come here was from UNESCO, is that right?
Yeah, that's right.
So we welcome you, and here's the title of her talk, I lost it. Water Security and Ecohydrological Solutions for Water Quality Improvements. Edyta.
Yeah. Thank you, Bill. First of all, I would like to thank you, Bill, for you and for your wife, Ruthie, Mitch, for invitation us here. It is a great pleasure for me and for my husband to be here today at very important symposium, very important event. Thank you again. So let's go. The title of my today presentation is Water Security and Ecohydrological Solutions for Water Quality Improvement. So in the first part of my presentation, I would like to show you some general view of environmental situation where we are as humanity. And then I would like to go to my studies, ecohydrological solutions for water quality improvement. So, ladies and gentlemen, please you can see that since 1950, this is the red color, we observed very fast exponential rise of many socioeconomic trends. So we can use that water consumption increase, primary energy use increase, real GDP increase, world population, urban population, large dam, also transportation, telecommunications, and so on, paper productions, and also fertilizer consumption. What is the answer of Earth system? Please you can see that we observed also since 1950, we observed exponential rise of carbon dioxide concentration, stratospheric ozone loss, marine fish capture, tropical forest loss, surface temperature increase, nitrous oxide concentration also increase, methane acidification, ocean acidification, and so on. So we also can see that climate change is affecting all regions in Europe and the world. For example, heat waves had increased in frequency and length. For example, the last decade between 2002 and 2011 was the warmest on record in Europe, with European land temperature 1.3 Celsius degree warmer than the pre-industrial average. What else? Various models show that Europe could be 2.4 Celsius degrees warmer in the later part of the 21st century compared to earlier period. What else? Global average sea level has risen by 1.7 millimeters a year in the 20th century and by 3 millimeters a year in the recent decades. The Arctic is warming faster than other regions. For example, record low sea ice was observed in the Arctic in 2007, 2011, and 12. What else? While precipitation is decreasing in southern regions, it is increasing in northern Europe. Why? Because climate change is projected to increase river flooding, particularly in northern Europe, as higher temperature intensify the water cycle. Please, you can see these pictures. This is my country. This is Poland during 2010, a very huge flood, and also in Slovakia. We also have problem with river flow drought, especially in Central Europe. Please, you can see this is my photo from France. This is Loire River, August 2015, and Vistula River the same period. So drought river. While there may be less water available for agriculture in southern Europe, growing conditions may improve in other areas. However, the yield is projected to fall due to heat waves and drought in Central and Southern Europe. So we can say welcome in Anthropocene. So you can see that now our population amount 7.2 billion people. You can see the scenarios for 2050. So maybe will be 9.3 billion people. Deaths and births 2 times higher. Yeah. So additionally, I find very good paper published in Science in 2015, where Stefan and co-authors find 9 planetary boundaries, and they show that a safe operating space for humanity are here. within which humanity can be continue to develop and therefore generators to come. And here you can see crossing these boundaries. This is this red color. For some boundaries like climate, some factors like climate, like biodiversity. Here we have genetic diversity. So we have sixth extinction period in the world, and also we are going to red color if we talk about land system change, freshwater use, biogeochemical flows. Ocean acidification is still in a green scale. So we should know that respecting the boundaries reduce the risk to human society. I would like to show you this factor for more detail. So please, you can see that safe zone, if we talk about concentration of carbon dioxide, is below 350 ppm. Yeah, and now we are somewhere here. So the question is which way we choose, this green or this blue color. I hope we will go to this blue color. Why? Because if not, we can go to high risk zone. It is around 550 ppm of carbon concentration of carbon dioxide. Of course, yes. Of course, climate change and planetary boundaries, but in the opposition is global capitalism. So we need the new transnational approach from a world economy to a sustainable global economy. Now I would like to go to water. So water resources in the face of global climate change became one of the most critical environmental factors that are point of crucial interest of the international society and the Millennium Development Goals. Please, you can see global population increase and the water consumption for particular kind of like agriculture, industry, municipal evapotranspiration, and so on. So still increase. We need more and more and more water. But scenarios are not good, because the World Resources Institute ranked 167 countries and found that 33 face extremely high water stress by 2040. You can see global situation for water stress, and especially will be found in countries like Brazil, Russia, India, and China. So scenarios are also that 4 billion people faced water scarcity. Water scarcity, this is describes as situation in which more water is withdrawn that the region can sustainable support. Now I would like to go to Europe and to Poland. Please, you can see this is the countries in Europe. Generally Europe water resources per one inhabitant is amount 2.5 times higher than in Poland, and amount 4,500 cubic meter per year. The situation in Poland is, like you can see, we are here. If we're talking about the hydrological conditions and geographical location with the temperate climate, water resources are small in Poland and amount 1,800 cubic meter per year per capita, but sometimes during drought seasons this could be below 1,000 cubic meter per year per person. But we also have a problem not only with water, but also with contamination. Please, you can see this is the classification of river and lakes water bodies based on water framework direction norms. This is situation in 2015. Please, you can see proportion of classified river and lakes water bodies in different river basins, holding less good ecological status or potential. So, for example, Poland is here. Germany and other countries. So contamination and eutrophication are currently regarded as the most serious ecological problem for surface water in the world. Of course, not only in America, but also in Europe. This is some aerial photos from south of Cornwall, Great Britain, and our Baltic Sea. We know that situation with water is not good. Therefore, generally with environmental is not good. So United Nations, we have United Nations Sustainable Development Goals. It was in 2015, 193 countries of the United Nations adopt the Agenda 2030, in which 17 common global sustainability goals were agreed on for the first time. And important is that for sustainable and safe future, we need, I think, something like this. This is like wedding cake, for example, where biosphere factors are the most important, and here also wetlands are located, and then society factors, and then economy factors. And everything is for 17 goals, goal number 17, partnerships for the goals. And paradigm for the Anthropocene is that economy should be seen as a means to achieve social goals and generating prosperity within the limits of the Earth, not as an end in itself. So we can say that we are in the situation like this man. So we shouldn't stay in this place. We haven't stayed in this place. Therefore, we need transformative changes. Transformative changes are necessary. We need some innovation, some innovative solutions. We need new ideas, new paradigms, ecohydrology solutions, circular economy. Important also are wetlands as nature-based tool for water quality improvement. Why ecohydrology and nature-based solutions? Why wetlands are needed? Because we are living in the Anthropocene era, when almost 80% of our usable ecosphere has been converted and consumed by humans. We usually without understanding of full consequence of our actions. What is ecohydrology? So the major body of the ecohydrology is dual regulation. So regulation of biota by altering hydrology, and regulation of hydrology by shaping biota. Of course, important is that harmonization of ecohydrological measure with necessary hydrotechnical infrastructure, and integration of various regulators acting in a synergic way to stabilize and improve of water, of quality of water resources. So this is general view where humanity are. But now I would like to go to my ecohydrological study. So this is the, please you can see, this is the Baltic Sea and the Baltic Sea catchment. Yes, this is this red line. So long-term nutrient input to the Baltic Sea led to dramatic over-fertilization. Here you can see the total Baltic Sea drainage basin area and total supply inputs of phosphorus and nitrogen to the Baltic in 2010 and 2006. Please, you can see that in Poland, this is the population density. I describe shortly because this is important to know that, for example, population density is the biggest in Poland and Lithuania. Much different colors show the very good, and also you can see that Poland, for example, Denmark, and yes, also Lithuania. This is agriculture area, rather. Here you can see proportion of sources contributing phosphorus and nitrogen input to the Baltic Sea. So green color, this is diffuse load, and red, this is point sources. So you can see total summarizing total phosphorus and total nitrogen load to the Baltic Sea. But for me was important question: what is the hierarchy of factors exerting an impact on nutrient load to the Baltic Sea? therefore, I start to analyze this problem, and I start from analysis of my country. So this is a map of land use and topographic map, and you can see that, for example, land use structure amount, like you can see 52% of agriculture, 30 forests, and 18% other. We have two big river, Vistula and other river. Vistula is here, and other is here. So many activities in the Baltic Sea regions are conducted by HELCOM. Here you can see the values of average values of phosphorus and nitrogen input, and here you can see the plants crucial, important for clean water. Objective would be reduced annual for these values, 50,000 of tons of phosphorus and 137,000 tons of total nitrogen. So my study, the aim of my study was to evaluate, not only but our study with my husband also, was evaluate 23 factors, like you can see, that determine total nitrogen and total phosphorus to the Baltic Sea across particular countries, surrounding countries. So the factors was like you can see number of livestock, pigs, cattle, and so on, fertilizer consumption, agriculture area, forest area, municipal load, number of wastewater treatment plants, and so on, calculated per square kilometers. And we find the most important factors for total nitrogen and total phosphorus. Now we know that we should put more attention for food production, for pigs, cattle, and agriculture area, and also for population served by wastewater treatment plants, so to wastewater treatment, and also with total phosphorus. Many information are in our publication in Marine Pollution Bulletin. So I haven't more times, therefore I would like to go to not only from this area to the Pilica River catchment located in central Poland. So we also have problems with algae blooms. We have key ecological problems like point sources of pollution, non-point sources of pollution, and toxic algae blooms in the Sulejev Reservoir, which is located in central part of the Pilica River catchment. What about my research on wetlands and nature-based tools for water quality improvement? Please, you can see we also analyze rule of wetlands like this, located in the Pilica River catchment for sedimentation of fine grain flat sediments. We use some sediment trap. And maybe these values are not big, but if we If we start to calculate these values on a big scale, so the values are much higher. So retention, for example, our calculations show that based on digital terrain model, we calculate that during highest water level, the area, flooding area amount, like you can see, 1,007 hectares. Sediments load retention amount 560 tons of sediment and 129 tons of total nitrogen and 8 tons of total phosphorus. So general information is that natural wetlands in the river valley are very important for self-purification, for sedimentation of materials. Our another study show that not only sedimentation is important for river self-purification, but also natural autochthonic community like here with macrophytes. So accumulation of phosphorus in the wetland macrophytes, it was at the area of 26.6 hectares, amount 255 kilogram of phosphorus. It is near 10 kilogram of phosphorus per hectare. But we also should remember that after vegetation season, we should cut biomass and take from wetland. So our calculation also show that this big area, this is 40-kilometer section between between Przedwórz town and Sulejów town. So here sedimentation amount 9,700 kilogram of phosphorus. So we also should remember that just 1 kilogram of phosphorus can lead to 1 to 2 tons of algae blooms, algae biomass in the reservoir. So you can see how this natural valley, natural floodplain, river floodplain is important for quality improvement. Also publication. So our research also concentrate on quantification of nutrients outflow from wastewater treatment plants like here. So in Poland we have a big problem with small wastewater treatment plants because, like you can see, this is the smallest, medium, and the highest wastewater treatment plants. This is concentrations of total phosphorus and total nitrogen from these categories of size of wastewater treatment plants. So wastewater treatment directive norm for total phosphorus and total nitrogen are like you can see. So sometimes two times higher concentration we observed in wastewater than norm. So quantification of nutrients transfer along the Pilica River continuum show that at the last station we have some accumulation. We observed accumulation of total phosphorus and total nitrogen load, which flow to the Vistula River and then to the Baltic Sea. Therefore, we should have a good wastewater treatment directive projects for management, because, like you can see, this is distribution of wastewater treatment plants in the Pilica River catchment with domestic, industrial, and municipal wastewater treatment plants. So we know that we have 143 wastewater treatment plants, and in many plants the situation with quality of wastewater is not good. Here you can see the concentration, and this is concentration and load of dioxins and PCBs in the effluent discharged from wastewater treatment plants during high flow and low flow, and you can see that load which outflow from wastewater treatment plants to the river and then to the Baltic Sea is very, very high sometimes. Our publication. Therefore, we try to prepare some innovative nature-based solution system. This is a hybrid sequential biofiltration system dedicated for small wastewater treatment plants, with, like you can see, geochemical barrier with limestone, coal, and sawdust bed, and with biological barrier with macrophytes, like you can see, Glycera, Acorus, Typha, Phragmites. And yes, some photos from this construction time. And our results show that, like you can see, average reduction of phosphorus and nitrogen concentration flowing through the particular phase of the hybrid system was, like you can see, we get the maximum reduction of total phosphorus, soluble reactive phosphorus, total nitrogen, nitrate, and ammonium, particular values, but the mean reduction was, like you can see. We have a big problem because the system could be only in this channel, because this is private area, and here is also private area. So we can't have large system for this. Therefore, I'm sure that if the system could be larger, so the values will be very, very high. And you must know that this hybrid system are working still at original municipal wastewater produced still every day, every hour. Our analysis also should show reduction of total of PCBs, equivalent reduction, and now we are working on a new project. The aim of this project is develop solutions, some biotechnology products to reduce outflow of nutrients from point sources of pollution, like organic manure plate and sequential sedimentation biofiltration system. The innovation is that we should prepare module hybrid products, easy to transport, easy to install, and delayed after the operation time. Yeah, this is some photos, and this is the place where we, in September, we will start to construct the system, like you can see. Sorry, this is in Polish language. And the end, because time is over, so I would like to say that floodplain wetlands, we need a more proactive approach to environmental river engineering, and river floodplain rehabilitation and restoration would be many positive effects for the inhabitants. This is important because we need compensation of climate change, improve water quality in rivers, in reservoirs. Yeah, and also this is important for conservation of biodiversity. So some selected references of this research, acknowledgements. It was three projects from National Science Center, Polish Ministry of Science and Higher Education, and at the end, I would like to say that we can achieve prosperous future within the safe operating space if we move simultaneously, collaborating from a local to global scale in transformative options which build resilience on a finite planet. So thank you.
We have time for one quick question if anybody wants to learn more about Poland. Anybody? Okay, sure.
Bardzo dziękuję. Na perspektywy międzynarodowej jest bardzo ważny dla nas ten perspective na globalny. I had to say thank you very much for that perspective, that foreign perspectives and global perspectives are really critical to what we're doing here. And it's encouraging. So I did it in my best Polish. My wife is Polish. So I have a good teacher. But I'm a poor student. So but what you're doing, though, it is central. It's flat land. It seems very applicable to part of what we're facing in Florida and Ohio. We're very similar in both areas. And what I wanted to say is, are you getting support from local government, or is this a national thing, or is it academic? You know, I mean, where's your support coming from? And I'm particularly interested in utilities, those wastewater utilities, and do they help, or where's the support?
Yeah. I know. Yes, I'm academic, but our center, European Regional Center for Ecohydrology, have large cooperation with administration, with local and national administration. Therefore, we are very often we are invited as an experts for big project, and we get some money for example, big project of building of constructed of wetlands, and for example big reservoirs, because the most important is you know, Poland have very small water resources, so we have a situation like in United States that we have high water resources. We have rather small. Therefore, important from Polish point of view is to how retain water in a landscape, and not only how, but important is also, for example, wetlands, like Professor Mitch showed that. Because not only water retention is important, but also quality quality of this water. So sometimes we have a problem because we have ponds, yes, and we have toxic algae bloom in this. So we try to construct ponds, construct reservoirs, but with sedimentation sites, with wetlands, and yes.
Okay, all right.
Thank you.
Thank you.